Hi, in this video, I will share the solved previous year's question paper for the subject MCS 211, Design and Analysis of Algorithms. The first question is, what is an algorithm? What are its desirable characteristics? A procedure for solving a mathematical problem in a finite number of steps that frequently involves recursive operations. The diagrammatic representation is as follows. Problem. A problem can be defined as a real-world problem or real-world instance problem for which you need to develop a program or set of instructions. An algorithm is a set of instructions. Algorithm. An algorithm is defined as a step-by-step process that will be designed for a problem. Input. After designing an algorithm, the algorithm is given the necessary and desired inputs. Processing unit. The input will be passed to the processing unit, producing the desired output. Output. The outcome or result of the program is referred to as the output. Types of algorithms. Brute force algorithm, a straightforward approach that exhaustively tries all possible solutions, suitable for small problem instances, but may become impractical for larger ones due to its high time complexity. Recursive algorithm, a method that breaks a problem into smaller, similar subproblems, and repeatedly applies itself to solve them until reaching a base case, making it effective for tasks with recursive structures. Encryption algorithm, utilized to transform data into a secure, unreadable form using cryptographic techniques, ensuring confidentiality and privacy in digital communications and transactions. Backtracking algorithm, a trial-and-error technique used to explore potential solutions by undoing choices when they lead to an incorrect outcome, commonly employed in puzzles and optimization problems. Searching algorithm, designed to find a specific target within a dataset, enabling efficient retrieval of information from sorted or unsorted collections. Sorting algorithm, aimed at arranging elements in a specific order, like numerical or alphabetical, to enhance data organization and retrieval. Hashing algorithm, converts data into a fixed-size hash value, enabling rapid data access and retrieval in hash tables, commonly used in databases and password storage. Desirable characteristics of an algorithm. Correctness. An algorithm should produce the correct result for all valid inputs. It should accurately solve the problem it was designed for. Clarity. Algorithms should be expressed clearly and understandably, making it easy for humans to follow the steps. This aids in both comprehension and implementation. Efficiency. Algorithms should be designed to be efficient in terms of time and space. They should accomplish their tasks using the least possible resources, ensuring optimal performance. Finiteness. An algorithm must have a finite number of steps. It should eventually terminate, providing a result within a reasonable amount of time. Generality. Ideally, an algorithm should be applicable to a range of inputs and not be limited to specific cases. It should be versatile enough to handle variations of the problem it addresses. Feasibility. The steps in an algorithm should be feasible to execute, both in terms of computational resources and practical considerations. Modularity. Algorithms can be divided into modular components, making them easier to understand, implement, and maintain. Each module serves a specific subtask. Robustness. An algorithm should be able to handle unexpected inputs or variations in input data without producing incorrect results or crashing. These characteristics collectively contribute to the effectiveness and reliability of algorithms, ensuring their utility across various applications in computer science and problem-solving domains. The next question is, what are asymptotic notations? Explain. Any two asymptotic notations, with suitable example for each. Asymptotic notations are mathematical tools used in the analysis of algorithms to describe their behavior and efficiency in terms of input size. They provide a way to express the growth rate of algorithms' time or space complexity as the input size approaches infinity. Two commonly used asymptotic notations are big O notation, O, and theta notation, theta. Big O notation, O. Definition. Big O notation describes the upper bound of an algorithm's growth rate. It provides an upper limit on the rate of growth, indicating the worst-case scenario. Example. If an algorithm has a time complexity of O, n squared, it means that the algorithm's running time grows quadratically with the size of the input, n. An example is the bubble sort algorithm, which has a time complexity of O, n squared, in the worst case. Theta notation, theta. Definition: theta notation provides a tight bound on the growth rate of an algorithm. It represents both the upper and lower limits, indicating a precise description of the algorithm's performance. Example: if an algorithm has a time complexity of theta, n, it means that the running time grows linearly with the size of the input. An example is a simple linear search algorithm, where the time complexity is theta, n, in the average and worst cases. These notations help express the efficiency of algorithms in a concise and standardized manner, allowing for easy comparison and analysis. Other asymptotic notations, such as omega notation, omega, for lower bounds, can also be used for a more comprehensive analysis, but big O and theta notations are commonly employed in algorithmic analysis and design.